Jai Hind. In the last class we have studied what is Coulomb's law, what is the mathematical expression of Coulomb's law. In this class we are going to study how will you express Coulomb's law in vector form. Expression of Coulomb's law in vector form. Since force is a vector quantity, it is better to write Coulomb's law in vector notation. First we can consider the case Q1, Q2 greater than 0, which means both the charges are either positive or negative. Q1, Q2 greater than 0. That's the first case. Consider two charges Q1 and Q2 separated by distance r. Here we can consider two force vectors. Vector F12. Vector F12 is the force acting on Q1 by Q2. Second one is vector F21. Vector F21 is the force acting on Q2 by Q1. So there are two force vectors, vector F12 and vector F21. Similarly, there are two position vectors. Even though r is the distance between Q1 and Q2, in order to express position vector in vector form, we have to consider two position vectors. What are they? Vector R12. Vector R12 is the position vector from Q2 to Q1. Vector R12 is the position vector from Q2 to Q1. Second one is vector R21. Vector R21 is the position vector from Q1 to Q2. Okay, so vector R21 is the position vector from Q1 to Q2. So there are two position vectors and there are two force vectors. Now, how you represent the direction of vector F12? Vector F12 is the force acting on Q1 by Q2. So what happens to Q1? Q1 is repelled by Q2 because both are positive charges or both are negative charges, like charges. So Q2 repels Q1, and so in which direction Q1 moves? Q1 moves away. Due to the repulsion, it moves away. So this is the direction of vector F12. Clear? So force acting on Q1 by Q2, therefore Q2 repels Q1, and in which direction Q1 moves? Q1 moves away, repelled away. Right. Similarly, what is vector F21 direction? Vector F21 is the force acting on Q2 by Q1. So similarly, Q1 repels Q2, isn't it? Both are positive or both are negative. Therefore, Q1 repels Q2, and hence in which direction Q2 moves? Q2 also moves away. So this is the direction of vector F21. F21 means force acting on Q2 by Q1. Therefore, Q2 is repelled by Q1, and hence in which direction Q2 moves? It moves away. So this represents the direction of vector F12 and vector F21. Similarly, how will you represent the direction of vector R12 and vector R21? Vector R12 means position vector from Q2 to Q1. Position vector from Q2 to Q1. So this represents the direction of vector R12. Clear? It is a position vector from Q2 to Q1. Okay, that is the direction. So this represents the direction of vector R21. Position vector from Q1 to Q2. So that is the direction of vector R21. So in the figure, it is clearly explained the direction of two force vectors and the two position vectors. Now we can see how you express vector F12. Vector F12 according to Coulomb's law, it is 1 by 4 pi epsilon 0 Q1 Q2 divided by the distance, isn't it? Since vector F12 is towards left, that direction is represented by the position vector vector R12. Clear? So it is R12 square into its direction is represented by unit vector R12. So unit vector R12, the direction of unit vector is same as the vector R12, and vector F12 can be represented as 1 by 4 pi epsilon 0 Q1 Q2 divided by the distance R12 square into that direction is represented by unit vector R12. Similarly, F21 can be represented as vector F21 equals 1 by 4 pi epsilon 0 Q1 Q2 divided by the distance, the direction of vector F21 is towards right. So that the direction is represented by R21 square into direction is represented by unit vector R21. So here this is the notation of Coulomb's law in vector form. Vector F12 is 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square into that direction is represented by unit vector R12. You know what is unit vector? Unit vector means it is a vector having unit magnitude, magnitude 1 and having a definite direction. Clear? And the direction of unit vector R12 is same as that of vector R12. And F21 can be represented as 1 by 4 pi epsilon 0 Q1 Q2 divided by R21 square into unit vector R21. So from the magnitude we can say that both the magnitudes are equal. F1 by 4 pi epsilon 0 Q1 Q2 by R12 square and 1 by 4 pi epsilon 0 Q1 Q2 by R21 square. If you consider the magnitude of R12 and R21 are equal but directions are opposite, isn't it? So magnitude of vector F12 and vector F21 are equal. Magnitude wise both are equal, but what happens to direction wise both are opposite. So here we can write vector F12 equals minus vector F21. Clear? So magnitude wise both are equal but direction wise they are opposite. So vector F12 equals minus vector F21. What does it mean? This is called Newton's third law. Okay, action and reaction are equal and opposite. Here also the two forces are equal and opposite. This is Newton's third law and hence we can say that Coulomb's law is in accordance or it is in agreement with Newton's third law. Clear children? So this is the expression of Coulomb's law in vector notation. Now we can see the second case, Q1 Q2 less than 0. Q1 Q2 less than 0, which means one charge is positive and other charge is negative. If one is positive and another one is negative means Q1 into Q2 is less than 0. Will be negative, isn't it? So Q1 Q2 less than 0 means one charge is positively charged and another one is negatively charged. So here these are the two charges Q1 and Q2 separated by a distance r. Here one charge is positive and another one is negatively charged. So how you represent the two forces vector F12 and vector F21? Here since one is positive and another one is negative, both gets attract. So force acting on Q1 by Q2. Q2 attracts Q1, isn't it? Q2 attracts Q1 and hence in which direction Q1 moves? Q1 moves towards the charge. So this is the direction of force acting on Q1 by Q2. Similarly, force acting on Q2 by Q1. Q2 is again attracted by Q1 and hence in which direction Q2 moves? Q2 also moves towards the charge. So this is the direction of vector F21. Clear children? So vector F12 and vector F21. Here also magnitude wise both are equal and directions wise they are opposite. Hence here if Q1, Q2 less than 0, one charge is considered as positive and another one is negative. F12 and F21 are equal and opposite. And here also we can say that it is in accordance with Newton's third law. Now we can discuss force between multiple charges. We know Coulomb's force between two charges is given by F equals 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. If there are so many number of charges, how will you find out the force on any one charge? For better understanding, here we can consider three charges Q1, Q2 and Q3 and they are separated by distance. Okay, here Q1 and Q2 separated by R12, Q1 and Q3 separated by R13. Here we can find out the net force on the charge Q1 due to Q2 and Q3. There are two forces acting on the charge Q1. F12, that is a force acting on Q1 by Q2 and vector F13, that is a force acting on Q1 by Q3. How will you represent vector F12? Vector F12 is 1 by 4 pi epsilon 0 Q1 Q2 divided by the distance R12 square. And how will you represent the direction of vector F12? Force acting on Q1 by Q2. Q2 repels Q1 because assume that all are positive charge or all are negative charge, same charge. So Q1 is repelled by Q2 and hence in which direction Q1 moves? It moves away. So this is vector F12 along the line joining the two charges away. So force acting on Q1 by Q2 is 1 by 4 pi epsilon 0 Q1 Q2 by R12 square, and its direction is represented by unit vector R12. So this is the direction of vector R12 or unit vector R12. Second force is force acting on Q1 by Q3. Its value is again 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 square into, how will you represent the direction of that F13? Force acting on Q1 by Q3. Again Q1 is repelled by Q3 and hence in which direction Q1 moves? It repels away, along the line away. So this represents the direction of vector F13. Force acting on Q1 by Q3, Q3 repels Q1 and hence in which direction Q1 moves? Q1 moves away. So this represents the direction of vector F13 and this is the direction of vector F12. And this direction is represented by unit vector from Q3 to Q1, that is represented by unit vector R13. Position vector or unit vector from Q3 to Q1 is represented by unit vector R13. So in vector form, vector F12 is 1 by 4 pi epsilon 0 Q1 Q2 divided by R12 square into vector unit vector R12. Similarly, vector F13 is equal to 1 by 4 pi epsilon 0 Q1 Q3 divided by R13 square into that direction is represented by unit vector. This is the direction of unit vector R13 from Q3 to Q1. And here, how will you, so the two forces are acting in two different directions. How will you find out the resultant? Resultant is given by the vector addition. So net force acting on Q1, the net force acting on charge Q1 is, we can write vector F12 plus vector F13. Take the vector addition of the two forces. So total force acting on the charge Q1 is the vector sum of the two forces acting on the same charge. And this principle is called superposition principle. So superposition principle states that the total force acting on a charge is the vector sum of all the forces acting on the charge. So if there are number of charges Q1, Q2, Q3, Q4, etc., what is the total charge of any one charge? We have to find out the vector sum of all the forces acting on the same charge or on this charge. And this principle is called superposition principle. So superposition principle states that force on any one charge due to number of charges is the vector sum of all the forces on that charge due to other charges taken one at a time. Here the two forces acting on the charge Q1 are vector F12 and vector F13, and the resultant force is obtained as usual by the parallelogram law of vector addition. We can complete the parallelogram and the diagonal of the parallelogram gives the resultant force. The magnitude of the resultant force is given by root of F12 square plus F13 square plus 2 F12 F13 cos theta. Okay, so using the parallelogram law of vector addition, we can find out the resultant of the force acting on the charge Q1. Four-point charges 2 microcoulomb, minus 5 microcoulomb, 2 microcoulomb and minus 5 microcoulomb are placed at the corners of a square ABCD of side 10 cm. What is the force on a charge of 1 microcoulomb placed at the center of the square? From the question, we can draw the figure like this. 4 charges are placed at 4 corners of the square and 1 microcoulomb charge is placed at the center of the square. We have to find out the net force on 1 microcoulomb placed at the center. How many forces are acting on that 1 microcoulomb? There are 4 forces acting on 1 microcoulomb. Force on 1 microcoulomb by a charge at A. Force on 1 microcoulomb by charge at B. Force on 1 microcoulomb by charge at C. Similarly, force on 1 microcoulomb by charge at D. Then we can find out the vector sum. That is a method. First we can write force on 1 microcoulomb by the charge at A. That can be represented as FOA. force acting on 1 microcoulomb by the 2 microcoulomb. We can use any notation. Here I am taking FOA. What does it mean? Force acting on O by A, or force acting on 1 microcoulomb by the charge at A. So FOA can be vector. FOA is 1 by 4 pi epsilon 0 into, these are the two charges, no? So 1 microcoulomb into 2 microcoulomb. We can convert a microcoulomb to coulomb. 1 microcoulomb is 10 raised to minus 6 coulomb. So here we can write 10 raised to minus 12. 10 raised to minus 6 into 10 raised to minus 6. 10 raised to minus 12 divided by the distance. What is the distance? OA square. Clear? And what is the direction of that force? Force acting on 1 microcoulomb by 2 microcoulomb. So 1 microcoulomb is repelled by 2 microcoulomb because both are positive charge. So 1 microcoulomb is repelled by the 2 microcoulombs. Therefore, in which direction it moves? It moves away like this. So this is the direction of FOA. Clear? Now, what is FOB? Force acting on 1 microcoulomb by a charge minus 5 microcoulomb. It is again represented by 1 by 4 pi epsilon 0. 1 microcoulomb into 5 microcoulomb. No need to put the negative because according to Coulomb's law we have to consider only the magnitude. So 5 into 10 raised to minus 12 divided by what is the distance? OB square into what is the direction of that FOB? The 1 microcoulomb is attracted by minus 5 microcoulomb. So in which direction it moves? It attracts. So this is the direction of FOB. Because 1 microcoulomb is attracted by minus 5 microcoulomb. Therefore, in which direction 1 microcoulomb moves? Towards. Now, next one FOC. That is 1 by 4 pi epsilon 0 into force between O, 1 microcoulomb and 2 microcoulomb. Again, 1 into 2 into 10 raised to minus 12 divided by which distance? OC square. Isn't it? And we can mark the direction. What is the direction of FOC? Force on 1 microcoulomb by 2 microcoulomb. 1 microcoulomb is repelled by the 2 microcoulomb, and hence in which direction this 1 microcoulomb moves? It repels away. So this is the direction of FOC. Now the last one, FOD, force acting on 1 microcoulomb by the charge minus 5 microcoulomb. Again it is 1 by 4 pi epsilon 0, 1 into 5 into 10 raised to minus 12 divided by OD square into what is its direction? 1 microcoulomb is attracted by minus 5 microcoulomb, and hence in which direction this 1 microcoulomb moves towards, isn't it? 1 microcoulomb is attracted by this charge at D, therefore it moves towards. So this is the direction of FOD. Clear, children? So if you compare FOA and FOC, if you see FOA and FOC, magnitude wise both are equal, isn't it? 1 by 4 pi epsilon 0, 1 into 2 into 10 raised to minus 12 divided by OA square. Here also the same value. And all the distances OA, OB, OC and OD, they are equal. So if you compare FOA and FOC, magnitude wise both are equal. FOA and FOC, magnitude wise equal, but directions are opposite. So what is the resultant? Since they are in the opposite direction, resultant force is 0. We can subtract. If two vectors are in the opposite direction, we can just subtract FOA minus FOC. Here both the magnitudes are equal, therefore resultant is 0. Similarly, compare FOB and FOD. If you compare FOB and FOD, here also magnitude wise both are equal. And what about the direction? Direction wise they are opposite. Here also the resultant of FOB and FOD are 0. Okay, that resultant is also equal to 0. So the total force acting on that 1 microcoulomb is equal to 0. Why? Because FOC and FOA are equal and opposite. Similarly, FOB and FOD are equal and opposite. Therefore, resultant force acting on 1 microcoulomb is 0. Second question, three charges Q, Q, minus Q are placed at the vertices of an equilateral triangle as shown. What is the force on each charge? According to the question, we have to find out force on the charges Q1, Q2 and Q3. First we can find out the force on the charge Q1, on charge Q1. How many forces are there acting on the charge Q1? There are two forces. Force acting on Q1 by Q2, force acting on Q1 by Q3. First, force acting on Q1 by Q2. It can be represented as F12. F12 is the force acting on Q1 by Q2. How do you write the formula? It is equal to 1 by 4 pi epsilon 0 Q1 Q2. Here the charge is Q, Q2 is also Q. Therefore we can write Q square divided by what is the distance? L square. Okay, and how you represent the direction of F12? Q1 is repelled by Q2. So in which direction Q1 moves? It moves away. So this is the direction of vector F12. Now, what is the force acting on Q1 by Q3? It can be represented as F13 equals 1 by 4 pi epsilon 0 into Q1 into Q3. Here Q, here it is minus Q, but no need to take the negative sign because according to Coulomb's law we have to consider only the magnitude. So here also Q square divided by L square. And what is its direction? Force acting on Q1 by Q3. Q1 is attracted by Q3, isn't it? Because one is positive, another one is negative. So Q1 is attracted by Q3, therefore Q1 moves towards the charge. So this is the direction of F13. Now what is the net force acting on the charge Q1? One force is acting in this direction, another one is acting in this direction. And how will you find out the resultant? Resultant is given by parallelogram law of vector addition. Now, how will you find out the resultant? Resultant of the force acting on the charge Q1 is given by the parallelogram law of vector addition or by using superposition principle. So, resultant for net force on charge Q1 is vector F1 equal to vector F12 plus vector F13 is equal to, how will you find out the magnitude of the resultant force? It is given by root of F12 square plus F13 square plus 2 F12 F13 cos theta. Okay, for simplification, here this F12 and F13 are magnitude wise equal. For simplification, here we can write let this is equal to x and this is also equal to x, so that it can be simplified easily. So root of F12 square can be written as root of x square. So it can be written as root of F12 square is x square and F13 is also x. Therefore here it is x square plus 2 x square. F12 and F13 we have taken it as x into cos. What is the angle between F12 and F13? The angle is equal to, what is that angle? That angle is 120 degree. So here it is 120. Clear? So root of x square plus 2x square cos 120. And what is the value of cos 120? Cos 120 is minus 1 by 2. After simplification, we get the answer as root of x square, which is equal to x, that is 1 by 4 pi epsilon 0 q square divided by L square. So the direction of the resultant force is given by the parallelogram law of vector addition. We can complete the parallelogram like this. And the direction of the resultant is given by the diagonal of the parallelogram. So this is the direction of the resultant force F1. Okay, so the direction of the resultant is given by parallelogram law of vector addition and magnitude is given by root of formula a square plus b square plus 2ab cos theta, that formula. So you can find the resultant of the net force or resultant force acting on the charge Q1 as 1 by 4 pi epsilon 0 q square divided by L square. Next we can see the net force acting on the charge Q2. On Q2, how many forces are acting? Here also there are two forces acting. Force acting on Q2 by Q1 and force acting on Q2 by Q3. Force acting on Q2 by Q1 is 1 by 4 pi epsilon 0 q1 into q2. Here also q square divided by L square. Clear? And what is the direction of that force? That force is here. Q2 is repelled by q1, therefore q2 moves away. So this is the direction of F21. Now, force acting on q2 by q3. It is 1 by 4 pi epsilon 0. Force acting on q2 by q3. Here also q square divided by L square, and q2 is attracted by q3. Therefore, in which direction q3 moves? It moves towards the charge. So this is the direction of F23. Here also the two forces are in the two different directions. What is the angle between them? Here also angle is 180 because this is an equilateral triangle, no? So all the angles are 60 degree, therefore this angle is 120 degree. And how will you find out the resultant? Here also resultant is given by the parallelogram law of vector addition. Here also we can find out the resultant force acting on the charge q2. For simplification, F21 is equal to x, F23 is equal to x, and the resultant force acting on the charge q2 is root of x square plus 2x square cos. Angle between them, angle is 120 degree. After simplification, cos 120 we know it is minus 1 by 2. So after simplification, here the answer is root of x square and the same as 1 by 4 pi epsilon 0 q square divided by L square. So the resultant force acting on the charge q2 is 1 by 4 pi epsilon 0 q square by L square. And the direction of the resultant is given by which rule? Parallelogram law of vector addition. Here also we can complete the parallelogram. The diagonal of the parallelogram is the direction of the resultant force F2. And the last part is we have to find out the force on the charge q3. Here, how many forces are acting on the charge q3? Two forces are acting. Force acting on q3 by q1, force acting on q3 by q2. Force acting on q3 by q1 is same as before, 1 by 4 pi epsilon 0 q square divided by L square. And what is the direction of that force? Force acting on q3 by q1. q3 is attracted by q1 and hence in which direction q3 moves? q3 moves towards the charge. So this represents the direction of F31. Clear? q3 is attracted by q1 and hence it moves towards. Now what is the force acting on q3 by q2? That is F32 equals 1 by 4 pi epsilon 0 q square divided by L square. So that q3 charge is also attracted by q2. Clear? q3 is attracted by q2 and hence in which direction q3 moves? q3 also moves towards the charge q2. So this represents the direction of F32. F32. Now, how will you find out the direction of the resultant, or how will you find out the resultant force acting on the charge q3? That is also given by which rule? Parallelogram law of vector addition. Resultant force acting on the charge q3 is given by the parallelogram law of vector addition. Here we can take, for simplification, F31 is equal to x, F32 is equal to x. So how will you find out the resultant force acting on the charge q3? It is given by root of x square plus 2x square cos. What is the angle between these two forces? The angle between these two forces is equal to 60 degree because it is an equilateral triangle. So here we can substitute cos 60. Now after simplification we get root of x square plus 2x square into cos 60. What is the value of cos 60? 1 by 2. So here it is 1 by 2. These 2 and 2 get cancelled, and after simplification the answer is root of 3x square, or it is net force acting on the charge q3 is F3 equals root 3x. What is the value of x? 1 by 4 pi epsilon 0 q square divided by L s square. So the total force or the net force acting on the charge Q3 is root 3 1 by 4 pi epsilon 0 Q square divided by s square. And what is the direction of the resultant force acting on the charge Q3? Using the parallelogram law of vector addition, we can complete the parallelogram. Here we can complete the parallelogram. Here also we can complete it. So the direction of the resultant is given by the diagonal of the parallelogram. That means in which direction? Downward direction. So the direction of the resultant force acting on the charge Q3, this is given by F3, vector F3. So these are the three forces acting on the charges Q1, Q2 and Q3, and it can be calculated by using parallelogram law of vector addition. Thus today we have seen how Coulomb's law can be represented in vector notation and the related to numericals. Hope you understood the concepts clearly. Thank you.